Hello everybody, today we'll talk about the Go learning and specify in my case the Go learning by project, the project called Souin. You have QR code to be able to retrieve my slides on slides.com. Before dive into the subject, let me introduce myself and make my self-promotion to you. My name is Sylvain Combraque. I'm from Lille in France. And sorry for my baguette accent, but I try my best to speak as well as possible. You can find me on GitHub, searching Træfik and Træfik_dev for Twitter. I'm creator of a cache system called Souin, written in Go. I'm Træfik helper, Træfik ambassador, and an active open source contributor and freelance too. So after that, we can dive into the beautiful world of Go and see together what are the issues in Go, and I'll try to teach you what are the main conflicts with Go. We will talk about Golang history because Go is a very young language. It started in 2003 at Google, but open sourced on 2009 by Francis McCabe and Case Clark. Google tried his own language to answer some performances issues. It's written in C, but you don't have to know C language to code in Golang. The advantages of Go is you have one binary file as output. You can build cross-platform for macOS, Windows, and Linux, for example. It's really easy to learn Golang. You can do multi-threading and concurrency really easily. And it's really easy to learn it because it's not a tricky language. Here are some softwares using Go. The first one is Docker. It's a famous one. It's the soft to manage containers, for those who don't know. And the second one is Kubernetes for the open source name, and Borg for Google instance. It's an orchestrator to manage containers, and you have other softwares like Træfik or Mercure. But Go is not really for ops, and you can do some web app for using Go. For example, Hugo is a static website generator from Markdown and YAML configuration file. You can do a fail to ban like using bad actor, and you have a reverse proxy called Caddy to serve PHP app or any web app instead of using Nginx, Apache, or any other reverse proxies. So what is my history with Golang? Let me replace the context. I'm Træfik contributor and Træfik user since 1.4. I'm also helper and Træfik ambassador, so any other names to describe this. And for those who don't know Træfik solution yet, it's a reverse proxy written in Go to help you to manage container architectures, and it's a container first approach. It's designed to manage containers. It supports the hot detection deployment, the scaling. It load balances your request automatically, only a specific port for all protocols. Then Træfik manage for you the service resolution depending host in entry. Then it's the pivot point of your infrastructure. And after months to use this solution, there was an issue I was facing too. There wasn't any cache system internally to Træfik, and all requests would have to resolve the associated service. Then it took many milliseconds to be done. And I searched after a cache system solution, but nothing appeared to be as efficient as I wanted, or it was only POC. So after many nights spent to look after that, I decided to create my first program in Go, because Træfik is written in Go too, and it sounds good. So this project called Souin is actually in version 1.5.2. And for the records, the release names are 3 beer names because I love to drink beers. So we reached over the 100 stars and don't forget to leave one because I've got an oversized ego and I like to view the stargazers count growing. So the first thing in Go I have to teach you is that Golang is normalized through some variable environment variables like the Go path. The Go path will tell to Go where to find binaries, where to find your sources, your dependencies, and the normalized architectures. So under your Go path, it's a normalized architectures. You have a bin folder, pkg folder, and src1. And I made a table to resume what is the goal of which folder. So sources contains the readable development sources with your dependencies. The pkg contains co-package objects compiled from src directory and your Go source code packages. And your bin folder contains fully compiled Go softwares based on pkg objects. Then after the Go path, you have your Go root, which is the Golang SDK path. It tells to Go which version it has to use. And you have one of the most the most useful environment variable, the Go OS. It tells to Go which kind of OS it has to build for. By default, it will use the host OS. If you are on macOS, it will use Darwin. On Linux, it will use Linux, and Windows, it will use Windows. So Go OS isn't really important as standalone environment variable, but you can combine it with the Go arch to tell Go to build, compile for a specific arch with a specific OS. With that, you can do a cross-platform build and build for Windows, even if you are on macOS. And AMD 64 with an RAM laptop. So you can do some matrix to build for any OS with any possible architectures. So it will generate over hundreds binaries, but you'll cover every systems with that. So now we can go to the next section, which is the live demo. You have QR code and the plain URL to clone the repository and practice with us during this session and learn to develop in Go. The first thing to do with Go is the hello world. So let's see together how to do our first hello world. Then we will deep dive into the language complexity and concepts in Go. So let's begin together. I just clone the repository. We have a main.go file to tell Go it is our entry point. We can run only main packages with a main function with Go. So if I try to run my main package, I can just type go run main.go and it will run my Go file. So if I do that, I'm absolutely doing nothing in my script. So let's type a simple hello world in the console. So we have the fmt package, which expose some methods to be able to debug our code or print something in the console. So we will print with a new line our hello world. It's a little bit laggy because I'm recording, so sorry for the inconvenience. Then if I save and I run main.go, it prints hello world in the console. Now we have our first hello world working, we have a hello world in the console, but the softwares we build with Go are not easy like a simple hello world, and because we want to make some calculations or any other operations. So let's see together on advanced mode of Go. It's Go routines. The Go routines are basically a part of a logical thread. Then Go sits on it to be as efficient as it is, because the whole language is built around the Go routines. So let me explain more precisely what is it. It's asynchronous, detached from the main thread. Then if you kill your main thread, the Go routine won't be able to talk with your terminal or your instance, the instance it was called by. So we have to take care about keeping the main thread running to be able to get back the data and be sure the Go routine is finished once the main thread will be closed. So let's see together how it works. Okay, so now I commented my hello world print, and we can go under Go routines folder and create a main.go file. After that, we create a function called Go routines. It will return absolutely nothing, and we can do a simple loop. For an iterator initialized at 0, we can tell if it's under 10 with an incrementation by 1, just print something, and it will be printf. Then from the main thread, the main method, iteration, like that, and just pass our iteration. And we can tell that we have another function. This function will be called, for example, my detached function, like that, and just copy this. Or we can tell we will give it an iterator, like that, and that's it. So to call it, we can tell my detached function, pass an iterator, and we can share our iterator here between the detached function and the main function. But if I do that, it will be a synchronous way. So the first will be the detached function, then after he finished, it will run this part of code, but we want to run them as a detached mode and concurrency. So go run main.go. We have the main, obviously. Then we have our detached iterations, then after that the main iteration. So to run it as concurrency, just add the Go keyword before our function, then it will create a new logical thread and just run it inside it. Just run like that. So the main method iterate 10 times, but the detached one at the time to iterate only 4 times. Because the Go instantiation will take some microseconds, but during this time, as it in synchronous, our for loop will be running before the detached will start. So to be able to wait this, we could add a simple time.sleep, then tell, okay, you will sleep for 1 second, and I have my iterations, then it sleep for 1 second and close the main thread. So that's why we have our detach method here. So that's not a really clean way to do that. If you want to wait for goroutines, we have something from the sync package called wait groups. And what is a wait group? It's a pool of goroutine, and it will tell, okay, while all goroutines didn't finish, I will just wait for it. To achieve that, we have to define a variable called wg, for example, for wait group from the sync package, and wait group. After that, I can just tell, okay, my wait group will add a new asynchronous function, and we can just pass our wait group to our detach function. I will group my declarations, and here we want to pass our wait group. So it will be pointer because we don't have to copy our wait group pool. Then we could do just wg done, but it's cleaner to tell when before reach the end of the function. So you can use the keyword defer to delay the execution of what we placed after at the really end of the function. So we will delay the done, and now we can pass our reference like that, and now let's printf, println, and that's it. But if I do that, it will run, and it won't wait for our detach function end. And to do that, we can do just wg wait and just run like that. So we have the first iteration, the second, and even if I add some sleeping here, for example, millisecond, and I will do the same thing here, and here I will sleep for a half second. And now we have our detached between main method, and everything is running. And while we don't reach the end of the function, it won't close the goroutine, so it will wait for it. So now we've seen the easy way for managing goroutines, but we have another concept in Go called channels. So what is a channel? A channel is like a pipe between your main function and your goroutines. You can push and pull data inside it. You're able to tell, okay, I'm at this step, and if I send you that, you can do this, or okay, if I do that, you can close this, or like that. So let's see together how it works and what are the main issues. So now we can delete our Go routines. I will copy everything except the package name, that, and I can remove this. I will go inside channel folder, main.go, and just paste this. We can remove references to weight group, like that, like that. And now I would have to use the channel. So let's instantiate a channel, just temporize channel with make, and it's a channel, and my channel will contain only integer. We can pass absolutely anything, so interface or your type or anything else. That's just for the behavior, and tell to go, okay, I will send you that, handle it like that. So in my TMP channel, I can push data. So if I try to tell, okay, TMP chan, I want to push you an integer, then if I try to print this, I can do it like that. Then it will wait for an incoming value. So we send it here, and it will print this, and it will print if the channel is closed or not. And to block the main thread, we can do that. So while I don't receive value anymore after this and after this reading, I will block the main thread. So we have to edit our main function. So, oops, that's not routine, but channels, like that. So if I try to go run main.go, it will create a deadlock since all Go routines are not up anymore. But to patch this, I have to use my channel here. It will be an integer chan, and I can defer that 1 will be considered as true. And yep, so I will create a simple function, and I send data in it, and I have to pass my temporized channel. I do that. I would be able to read data in it, but it doesn't. But if I try to read data like that, then I get my 1. But here I don't get any data, and all Go functions are stopped. So we could just move this and replace the plain temporized channel, and to read data in it, can get the value and the open or closed, and just debug these values. And I got true because it's open, and 1 because I send the value 1 in it. But if I tell, okay, I will close my channel here, I don't want to get any data anymore to be pushed in it, I'm able to do that like this. And I consider that this will be longer than the temporized channel. Then doing that, I got 0, 0 because I've got nothing, and the default value is 0, 0 for an integer, and false because it's not open anymore. I think we've covered the main parts of the channels. Now I think we can go further and go the next step. And the next steps would be the testing, because I came from an environment that we didn't test really, we didn't test a lot. So while I'm discovering Golang, I discovered the unit testing, and Go is really well. It embed the test inside the language itself. So we could just comment this, and we can, I don't have folder containing test, so just create it, testing / or just test main.go. So we will have some functions like 2 is 2. So it will return a boolean, and here we take an integer and tell if n is equal to 2, and obviously I have to return this. For example, Frank like that, which will return an integer and return 2 plus 2. And if I want to go further, I can tell fizzbuzz like, so it will take an integer and return a string, and if n equal to 0, 0, I will return fizz and modulo that. Here I return buzz, and the default will return buzz, for example. So to test this, I have to export my function. We can create a Go file, your Go file underscore test. And if we want to create a function to be tested, generally it's an exported function, and it will ensure that, for example, test func 2 plus 2, it will use the testing package, and in that we can have some asserts, but that's really low level and you don't have any helpers. So my function 2 plus 2 will return 4. So if Frank 2 plus 2 is different than 4, we will throw an error. So error should return 4. Then if I do that, it will pass. So just run using an IDE, because I'm a nerd. Not really a nerd, but so it will compile, and I'm a noob. That's the good word. Then it's okay. My tests are green, and if I enable this and I say, okay, 2 plus 2 for me should return 3. then it will compile, then the test fail, and it should return 4. That's it. But if you're absolutely sure 2 plus 2 should return 3, so you can tell to your code, okay, just returns 3, and it's okay. So now we've done this. Func test. What are the other functions? 2 is 2. Like that. So it will implement the testing package and just tell if func2 is 2, 3. So if it returns true here, it shouldn't. Then just show 3 is not 2. And I will disable this. And if for the 2, it will return false. 2 should be. So that's really useless here, but that's for testing. So it will test any cases, like it's unit testing. And now we will test the fizzbuzz. And now we want to run this, what I've done in fizzbuzz. So if I try to return something like if fizzbuzz from 0 different fizz, I think. If it's different than fizz, then I can display an error message. For 0, it should return fizz, and if fizzbuzz 1, return buzz. No, buzz. Yep. And for 2, it should return buzz, and for this, it should return buzz. And that's it. So if I run it, we can see everything, every test path, and we can run tests like go test, and on each packages, and it works. But I prefer on my IDE because it's visual, and to explain it's simpler. So if you want to go further, you have a more explicit example with in the solution. You will run, what is the word? A web server. You will send JSON response and any other things using what we've seen together. So little useful tools. For example, for testing, you have GoTest, GoTool for tooling, and for linting and best practices, you have GoLint. It will tell you you're so bad, that's not the right way to do that. And the same thing for GoVet, but GoVet will handle any bad implementations or not just the syntax, for example. So here are some examples using that. Some useful commands, go imports, go fmt, etc. But I think you know already these commands. And some useful links, and thanks to Avellino for making this repository exist. It will aggregate the data related to Go language And if you want to read something, you'll find obviously on this repository. So you have Code Wars and Golang Challenge to challenge you on katas. So that's little exercise. It takes around 5 or 10 minutes to be done, and you can see the other responses when you find something working, and you can see a better comprehensions or faster script. And I'm working on other side projects. So I'm working on Smurf. That's an open source pen test oriented platform written in Angular for the front end, PHP for the back. That's a good project to help you to manage your pen test missions or just pen test. I created Souin WordPress repository to be able to manage Souin through a WordPress admin, and that there is the same thing for PrestaShop created by Luke. So take a look at this. That's a good project, especially for Smurf. And I think I'm done here. Thank you everybody for your attention, and I'm available to discuss about some things. So like Gordon Ramsay is saying, thank you so much, and thank you to Conf42 organizers team.